I want let's solve for question called longest repeating character replacement. So given string integer k, we can choose any character in string and change it to any other character in string. And we can perform this operation at most k times. This means exchange limit k. So it simplifies the purpose of the equation here. So find the length of longest repeating character in string within the exchange limit k. Okay, now let's check example to get the intuition. So in example 1 here we have this a b, right? So let me write that here. We have b, and our exchange limit k equal to 2. So we change this b with a and this b with a, and what will happen? So let me write it out here. I'm using different color. So see, we replace this 2b with 2a and we get this 4a, right? And the length of the 4a is 4, so we return 4. Okay, now let's check example 2, which have slightly longer strings. So this one is a, ba, and bba. Okay, and here the k, the exchange limit is only 1. And you see, if you change this b with a, what will happen? Let me write down here, some different color. If you change this b, we get this 4a, right? And the length is 4, so we just return 4 as our longest repeating letters. Okay, now finish the examples. You must give some intuition of this problem. Next thing to think how to solve this problem, right? And this problem, since we are finding the longest repeating letters, so it's maximum length problem for array, and we are using sliding window approach, which is both efficient and easy to understand. So let's reduce example 1 on the right side. So example 1, we have the string equal to AB, right? And let me write it here using the red color. String equal to AB, and k, which are bit string limit only 2. And the first thing for this approach is to initialize the condition to record the frequency of each letter. So let me write down here. And let's say the letter L is here, and this count, right? Okay. Once initialize dictionary, we can actually calculate the signing window. So initialize left pointer here, right pointer here. And besides, we need the current letter, maximum letter, right? And additionally, in the expression, we need the exchange limit, which I'll put in later. But here, let's initialize current length, maximum length 1. So our exchange limit, let's say it's EL, is calculated using the current length deducted by the maximum count in the dictionary. And let me show you how to derive this equation. So let's say our string is, let's use different color. Let's say our string, in this case we have AB, right? If our current length is 4, this means, okay, let's say the right pointer and go to this position, and current length is 4, and maximum length also 4. If that case, this one should be 4. And the maximum count, since we have 2a and 2b, this one should be 2. And the exchange limit is 2, right? So we can either exchange this b with a, this b with a, or we can change this a with b and this a with b. So we have use our exchange limit, right? Okay, I hope it will make some sense. Now let's go back to the initial condition. Okay, so changing this all and move the right pointer back to the original position. And this one, let's reset to 1, and this reset to 1, and reset the exchange limit to the original 0. Okay, now we have to actually calculate the exchange limit, but before that we have to record A and B, the letters in the string to our dictionary, right? So see left pointer, right pointer, both pointing A, so A here, and the count equal to 1. And in that case, the maximum the count is 1, right? But current length is still 1. So we still have this 0 here for the exchange limit. Now we have to keep moving because the exchange limit had not passed this 2. So moving by right pointer to the next position, we have B here. And we add this B to our dictionary. And let's say, okay, this here is 1. Okay, now the current length is 2, and also update the maximum length and 2. Write it here. And one feature that calculates the exchange limit, which is current length divided by the maximum count. So this one is actually 2 minus 1, right? So it's equal to 1. And you see 1 is still smaller than 2. This means we can still continue moving our right pointer. So moving right pointer to the next position to this A. And now the count for A should have to be 2. Okay. So just write it out here. Okay, so the next thing to update current length and maximum length. So let me write the current length here is 3 because the distance between the left pointer and the right pointer is 3, right? And also the maximum length should be set to 3. And so far the exchange limit should be current length so 3 divided by the maximum count, so 2. And it's still 1, it's smaller than 2. But to keep moving our right pointer to the next position, so let's move right pointer to this position, right? And if the right pointer at this position, the count for B is now 2. Write it here, 2. And the current length and maximum length should be updated to 4, right? So clear this all and write 4 for both lengths. And so far the exchange limit should be, so just write it here, should be 4 minus 2, right? So 2. But you see 2 is still smaller or equal than 2. So we still satisfy the requirement at this step. But actually, you see the right pointer is actually at the end of string, so we cannot move the right pointer further, and we have to stop this step. And once stop this step, we turn this maximum length, which is 4. Okay, so we return this one, and we're done. Okay, now finish the graphical explanation. Next thing to write code. So first, let me write out the general approach for this kind of problem, and then we can build in code quickly. The coding comments. Yeah. Just copy paste here to save some time. Okay, as I mentioned before, the first integration left pointer is 0, as we did in previous sliding window project. And then we need a counter to count all the nouns in the string. But here let's initialize empty counter. And after that, we want to initialize the maximum length, which is 0. Okay, now finish initialization. Let's run the pointer to expand our sliding window. So we're moving the right pointer all the way to the end, and I want to add a count at right pointer by 1, right? And every time we find, okay, if our exchange limit exceed the limit k, we have to move the left pointer to shrink our sliding window. So as mentioned before, the exchange limit right minus the length of 1. So this is the current length, and we are to deduct it by the maximum counter value. Use this expression in Python. If this exchange limit is greater than k, this means we have already surpassed our limit, right? So we have to move the left pointer. Before that, let's deduct the left element by 1, and now in the left pointer. Oh, sorry, here should be y. And after that, this means, okay, we have not exceed the exchange limit, so we have to update the window size. Okay, the current as I mentioned before is right plus left plus 1. And the maximum length is the maximum between the previous maximum length and current. Okay, once finish all this, the after to return the maximum length and we're done. Okay, let's submit the code still works. Okay, you see the time capacity memory used in this solution is not bad, right? And I think the code is short is and easy to understand. If you like this video, please subscribe to my channel, and I'll see you next time. Thank you.